Hello all, my name is Indra Maslan and I'm here to teach you Chemistry 5070. Starting with today's topic, the particulate nature of matter 2.2. We're going to start today with atomic structure, and let's go on to the learning objectives for today's class. We're going to state the relative charges and masses of the protons, neutrons, and an electron. And I'm also going to discuss the atomic structure. I will define proton number, nucleon number, and what are isotopes. And we are also going to deduce the number of protons, neutrons, and electrons in atoms and ions from their proton and nucleon numbers. Jumping on to the next slide. So this is the atomic structure. You guys might have seen in your chemistry books. So this is basically an atom. An atom is a smallest particle of an element, and it consists of electrons, protons, and neutrons. So electrons are represented by these yellow circles, and the protons, they are the positive green ones. The blue circles, they are represented by the neutrons. And the protons and the neutrons, as you can see, they are inside the nucleus of an atom, whereas the atom has shells. These shells, they carry the electrons. So protons, neutrons, and electrons, they are all referred to as subatomic particles. And the electrons, they are orbiting the nucleus of these shells, or the energy levels. This will be much further discussed in A-level chemistry. The neutrons, they do not carry a charge, which is why they are not positive or negative, and whereas they are represented by n, small n. The protons, they're represented by small p, they carry a positive charge, and electrons are represented by small e, they carry a negative charge. So one proton carries +1 charge, one electron carries -1 charge, and both the relative masses of the proton and the neutron, they are equal. So protons and neutrons, they have equal relative masses, which is 1. They both are present inside the nucleus, and the protons and neutrons, when they are joined together, we jointly call them as nucleons. Whereas if I talk about electrons, they are very light in weight, they carry a -1 charge, and their relative mass is literally negligible. I will tell you what their masses are, but we do not call that their relative masses is going to be 0. Okay, it is not at all 0. It carries some mass, but it is really negligible. And these electrons, they basically, they're very important. Why? Because they take part, they have a role in chemical reactions. So they're either they are transferred from an atom to another atom, and because of their transfer or their sharing, different bonds are created, ions can be created. So this is what happens. So all the relative masses of the subatomic particles, these protons, electrons, and neutrons, they are obtained from by dividing the mass of that particle by dividing it by the mass of a carbon-12 ion. So I'm going to write it here. It is basically mass of the particle itself divided by the mass of a carbon-12 ion. So it's C12 atom, sorry. So it's going to be like this. Right. Now let me show you their relative charges and their masses. So over here we have this is a very good table. You guys can just use it in your for preparation of your exams as well. So, and this is very easy. You can just remember it as quickly. It's very easy. Okay, so we have the protons. They carry the +1 charge. Electrons carry -1. Neutrons do not have a charge. Relative masses of protons and neutrons is the same, which is 1. And the electrons, they have the relative mass of 1 upon 1840. This is why they have a really negligible mass. Now, questions can even come up in your exams regarding these masses, and I will tell you how they can. So in this electronic arrangement, I'm going to share that how the electrons, they are accommodated in the shells, or they are also known as the energy levels. And this accommodation of the electrons in their shells or the energy levels is known as the electronic configuration or the electronic arrangement simply. And the supposingly, if I have to draw it and I have to show it to you guys. So the first shell is always filled up with, now this is a nucleus and it has neutrons and protons. Okay, the first shell always and always fills up with, it can hold up to 2. There can be less than 2, but it can hold up to 2 electrons. The rest, they can hold up to 8 electrons. So there can be less than 8. So it's going to be like this: 2 here, 2 here. This is a very simplified diagram for you all to remember. Okay, 2 here. So you have 4 and 4 here. So 2, 2, 4, 5, 6, 7, 8. Okay. So the rest of the shells, they can hold up to 8 electrons. It's not necessary that they need to have an 8 electron, but each and every atom, they just find their stability. They are much more stable when they are going to have the 8 electrons. Okay, so they want to get this octet configuration. This is known as octet. Carrying 8 electrons in the shell is known as octet configuration, whereas carrying 2 electrons in a shell is known as duplet configuration. So this is something which is usually seen in group 8 atoms, and this is why each and every element, they and each and every atom, they are dying to get this kind of configuration, because this is their stability. So all the shells or the energy levels, they are filled in the ascending order, and they are always filled from the first shell to the last, and the last shell is always known as the valence shell or the outer shell, and all the electrons in the valence shell or the outer shell, they are known as the valence electrons. What is the importance of these valence electrons? The valence electrons, they indicate basically the chemical properties of an atom or an element. And for example, if if an atom has one valence electron or 2 valence electron, their chemical properties, they are going to change. Okay, so this is why the valence electrons, they are of importance. And the atoms, they have if they have the same, for example, in group 1, all the atoms in group 1, they're all going to have the same valence electron. So this is something key concept, and this is a slight beginning of your periodic table as well. So in a group, all the atoms, they have the same valence electrons, which is why they carry the same similar chemical properties. Now coming to the next point, the electronic configuration or arrangement of electrons in their shells, they are shown below. So different electronic configurations are shown over here, and right here I'm going to tell you how this is made. So this is the proton number, or known as the number of protons. So these are the protons in particle X or in atom X. So this element has 15 protons. Same electrons, they have this X has going to have the same number of electrons, as it is not an ion, it has not transferred or shared any of them. So they're going to be equal in number. So we have to make the configuration and make it a total of 15. So as I told, first one is going to have 2, the next one is going to have 8. Now we have a total of 10 right now. So the rest which are left, or the last shell, they are going to have 5 electrons. That is why this element is going to be in group 5. Why it is going to be in group 5? Because the last number of valence electrons tells us their group as well. Okay, and this is also going to indicate their chemical properties. So this is going to be in group 5. Coming to the next one, this is S sulfur, 16 proton number, but has gained 2 electrons. 2 minus means 2 electrons have been gained. So now the electrons, they are how many? 16 plus 2, they're going to be 18 now. So please mind my, don't mind my writing. This is pathetic, I can write. So I'm going to use a text walk right now so that you can understand better. So it's going to be 2, 8, because first shell has always carry up to 2 electrons. The second one is always going to carry up to 8. Now we have 10 electrons up till now, and rest which are left, 18 minus 10 is going to be 8. So the last shell is going to carry 8 electrons. So this means the sulfur atom has gained 2 electrons and has now gained an octet configuration. So 2, 8 and 8. Now aluminium 3 plus, Al. So I'm going to first this one, Al 3 plus. 3 plus means it has given or transferred 3 electrons to some other atom. So it has lose its 3 electrons. So if 3 electrons have been loosened, so that means that now the electrons left are only 10. 13 minus 3 is going to be 10. So it's going to be 2 in the first one and 8 in the next one. So 2 comma 8. So this is how you make the electronic arrangement or configuration of the electrons in their respective shells. Coming to the next point, the elements, they are always arranged in a periodic table with their increasing proton number. Supposingly, first one is going to be hydrogen. Hydrogen has 1 proton number. Helium has 2. Then comes the rest. 3, 4, they're always going to be in the increasing proton number, right? The rows which are formed in the periodic table, these are the horizontal rows. They are 7 in number, and they are known as the periods. So there are basically 7 periods in a periodic table. The number of shells of an atom, how many, whatever the so you see the last valence electrons tells us the group, and the number of shells. Number of shells means this is 1 shell, the second shell, and the third shell. So you see 3 shells over here, and this is 1 shell, this is 2 shell, so this is 2 shells over here. So this is going to tell that in which period they are, but this only happens with the atoms or the elements which have not transferred any of their electrons. So if I say X has transferred none of its electrons, so it is in group 5 because of its valence electrons 5, and has 3 electron shells, or the energy levels, 3 energy levels. That is why it is going to be in period 3. So it is going to be in period 3, and there are total 7 periods in a periodic table. How many groups are there? Groups are the vertical columns. They are 8 in number. 8 groups in number. As told before, that the same number of valence electrons, all the atoms or elements in the same group have same number of valence electrons, and that is why they have a similar chemical properties. Now this was all for this slide. Coming to the next one. So this we have discussed this already, that the combination of the electrons in or the in the shells or the energy levels, they are called the electronic configuration. Coming to this one. So the proton number and the nucleon numbers. As I've discussed earlier, that I'm going to share something about the proton numbers and the nucleon numbers. So the atomic number or the proton number, they are represented by Z, capital Z. And the proton numbers, they are basically the number of the protons in carried by a nucleus of an atom. So the proton numbers, they are equal to the number of the electrons in an atom, not talking about any ions. Mass number or the nucleon number, they both are the same. They are represented by capital A, and this is the sum of the protons and the neutrons which is present inside the nucleus of an atom, and this is known as the nucleon number or the mass number. So this is going to be the sum of the protons and the neutrons. If I want to calculate, or someone wants to ask what is the number of the neutrons of an atom, how are you going to calculate? You are just simply going to subtract the proton numbers or from the nucleon number, A minus Z. And the symbol over here, for example, an element X is written over here. This is going to be the nucleon number, A, and the below one is going to be the proton number or the number of protons, which is equal to the number of electrons in the atom as well. And if you want to calculate the number of neutrons, you just are simply going to minus A minus Z, and you're going to get the number of neutrons. So different elements, they have the different proton number. Coming to the next slide now, I'm going to show you some few examples as well. Now I'm going to discuss something about the isotopes. Isotopes, they are the atoms of the same element, and but they are basically from the same element, but they have the different nucleon numbers, or they are atoms of the same element but having different mass numbers. Mass numbers and nucleon numbers both are same. So isotopes, they have the same proton number. Their proton number is exactly the same because they're from the similar elements, and they have the equal number of electrons as well. So proton number and and electrons, they are going to be the same always. The protons and electrons, they are always going to be the same in the isotopes, whereas the neutrons, they are different. Okay, the neutrons, they are always going to be different, which is why we have different nucleon numbers or different mass numbers. Over here we have two examples. We have carbon monoxide and carbon dioxide, CO2. They both are not at all isotopes because they both are compounds. Okay, so this is something not putting it into the theory of isotopes. Coming to this example, if someone asks you phosphorus 31 and 32, this is how you write it. 31, if you have an isotope, 31 dash P, 32 dash P. So they both are of them, they are isotopes of phosphorus because they have the same number of protons, as you can see, 15 and 15, and they have different number of nucleon, that is 31 and 32. This is why they have the different number of neutrons as well. So chemical properties of the substances, they depend upon the number of electrons in the outermost shell, and hence the isotopes, they are chemically identical because they have the same number of electrons. However, they have different physical properties because their relative masses, they are going to differ because of change in nucleon number or mass numbers. Coming to the next slide now. So these are the isotopes of hydrogen. Hydrogen has three isotopes, protium, deuterium, and tritium. First one, H1 has no neutrons. It has one proton, one electron. Deuterium has one neutron, one proton, and one electron. How did we calculate the neutron number? 2 minus 1, A minus Z. See? And this tritium was an artificially made isotope, and it is radioactive. So it has two neutrons. How come? 3 minus 1, A minus Z. Right? Now I'm going to share some uses of the radioactive isotopes as well. The radioactive isotopes, isotopes, they can be used in generation of power, to generate power in nuclear weapons. Phosphorus P32, it was used in the cancer treatment as well. Carbon-14 was used in carbon dating to find ancient ages. And isotopes, they are radioactive. They emit high energy radiation. That is why they are known as radioactive isotopes. Coming to the next slide now. So I'm going to discuss a few practice examples with you guys as well. This is a periodic table. I'm going to share how we can use this in our examples. So the first question over here is that a radioactive isotope of carbon has more nucleons than the non-radioactive isotope 6, 12, 12, 6. And how many protons, neutrons, and electrons could there be in this radioactive isotope of carbon? So they are asking that the radioactive isotope of carbon has more nucleons. More nucleons means more neutrons, right? The protons and electrons, they always remain the same in the isotopes. So if it is C, 12, and 6 written here, so 6 is the proton number, which means 6 number of protons and 6 number of electrons. We have 6 protons and 6 electrons, and this is always going to remain the same in the other isotopes as well. So this and this is right, and this is going to be incorrect. But we are saying that the other isotope of carbon has more nucleons, right? So more nucleons means the proton number, if the proton number is same, the neutrons are going to be greater. This means this one is going to be correct and this one is going to be incorrect. So B is the correct option. Coming to the next question, the symbols for two ions, they are shown. So we have fluoride and we have sodium. Which statement is correct? The fluoride ion has, first of all, we need to make the number of protons and neutrons and electrons as it was shown over here in this table. You have been given the data for the fluoride and for the sodium. I'm going to write it over here. Neutrons, protons, and electrons. So these are ions. So we have to be very careful regarding the electrons. Now the proton number. The proton number is written over here. For fluoride, it is 9, whereas for sodium, it is 11. The electrons, as minus means it has gained 1 electron. So 9 plus 1 is going to be 10. So it is going to be 10 electrons for fluoride. 11 protons, it has lost 1 electron. That is why it's going to be 10 now. 11 minus 10. Now 11 minus 1. Here 19 minus 9, we are going to get the number of neutrons, A minus Z. Remember, A minus Z is going to be 19 minus 9. So it's going to be 10. So we have 10 number of neutrons in fluoride, right? Whereas if I talk about the sodium, there is going to be 21 minus 11, which is going to be 10. So we have 10 number of neutrons in sodium. So you see that we have same number of neutrons in both the ions. different number of protons and same number of electrons. Coming to the options now. So the options state the first one is the fluoride ion contains more electrons than sodium ion. No, they have the same number of electrons. Sodium ion contains more neutrons than the fluoride. No, they have the same number of neutrons. So A and B both are wrong. Then C. The two ions, they contain the same number of electrons as each other. Yes, they both have 10 electrons. So this one is correct. Now the two ions, they contain the same number of protons as each other. No, one has fluoride has 9 protons, number of protons, and sodium has 11. So it's going to be wrong. So we have the correct one, which is C. The next one is the table contains information of the structure of 4 particles. Now, what are the values of W, X, Y, and Z in the table above? So you have to see the number of neutrons. You have to calculate these number of electrons, proton number, and this. So what can we find from the table, periodic table? We can find out the number of neutrons from the periodic table of magnesium. I'm going to go to my periodic table first. Here it is. Magnesium is in group 2. It has 24 nucleon number and 12 proton number. So magnesium has 24. This is why the neutrons, they are going to be 24 minus 12, which is going to be 12. W is going to be 24 minus 12, which is going to be 12. For the next calculation, coming to X. X is the number of electrons of magnesium 2 plus ion. So number of electrons, they are usually equal to the number of protons, but for ions we have to be very careful. So 12 number of protons, that means losing 2 electrons is going to be 12 minus 2, which is going to be 10. So 10 electrons for magnesium 2 plus ion. Then fluoride. Fluoride, we have to calculate the number of proton. Now you don't need to go to back again to the table. You already have the number of protons on the side column, which is 9. So the proton number is going to be 9. For Z, it is the number of electrons we have to calculate. It is again a fluoride ion, so we have to be very careful about that. And number of protons, they are 9. So obviously we're going to, it has gained 1 electron, minus means 1 electron has been gained. So 9 plus 1 is equals to 10. So 10 electrons for Z. Now if I check it from the table, W is 12. So W is 12. This one is wrong. So this option is now not needed. W is 12. All of these are correct. X is 10. So now you see this one is not needed. These two are absolutely correct. Now we have to check for Y and Z. Y is 9. So this one's correct, and Z is 10. You see, so this option is absolutely right. Coming to these few questions. Now here the first one is, which graph shows the number of electrons in the outer shell of an atom plotted against the proton or the atomic number for the first 10 elements in the periodic table. Now you have to be very careful. They have not said that the number of electrons of the whole atom. They have just said the valence, they have talked about the valence electrons or the number of electrons in the outer shell of the atom. These are the proton number on the x-axis, and on the y-axis you have the number of electrons in the outer shell. So first off, the first one is starting, if I start from 2. For proton number 2 proton number, we have 2 electrons. So helium has 2 proton number and it has same number of electrons in its outer shell because it has a duplet configuration, right? Then if I talk about beryllium, coming to my periodic table first, I'm going to show it to you. Yes, here. So first we have hydrogen, the next we have helium, then we have lithium. Now lithium is proton number 3, beryllium is proton number 4. So lithium is in group 1. That means the valence electrons are the outer electrons in the outer shell. They are 1 electron. So I'm going to show it to you in my next slide. So the proton with the 3 proton numbers, then outer shell electrons, they are 1. This this option is going to be the correct one. Coming on to the next question, a beam of particles, all of these options, they are all incorrect. Okay. A beam of particles contains neutrons, protons, and electrons, and the beam is passed between the charge plates. So you have to tell that how the particles, they are affected by the plates. Now the beam of particles, they have passed through these charge plates, which are positive and negative. And neutrons, first of all, we know they don't carry a charge, so they are not going to be deflected by any of these plates. Okay, so neutrons, they are going to be in the middle. Also only this and this one is going to be the correct one. So these and this is wrong. Now I'm going to only consider these two options. Then I'm going to come to the next one. Electrons, they carry a negative charge, so they are going to be always deflected towards the positive beam plate. So this is the positive beam plate, which is why electrons have been deviated over there. Now if I talk about the deflection angle, so you can see over here that protons, they have they are much more heavier as compared to electrons. Relative mass is heavier. Protons, they have a mass of 1, whereas the electrons, they have 1 upon 1840 mass, which is very least. They are negligible in weight. Because they are so light in weight, they will be deflected at a higher or at a much greater angle as compared to the protons. This is why the electrons, they have deflected much, and they are going to go nearer to the positive plate. Why? This is because they carry negative charges. They are always going to, as we know that the opposite charges, they attract together, so they attract to each other. This is why electrons, they go towards the positive plate, and protons, they're positive and they're going to deflect towards the negative plate. So guys, these were a few practice examples. If you have any further questions or queries, please comment down on this video below and ask me your queries. Feel free and I will reply to your queries. Thank you so much. Happy learning.